Hi, today we're going to be solving one-step equations. Equations are different from expressions in that equations have an equal sign. The equal sign means that equations have to be balanced. Whatever's on one side of the equation has to be balanced with whatever's on the other side of the equation. So in this example, on the left side we have 4 plus 12. On the right side, we have 16. This is balanced because 4 plus 12 is equal to 16. You've been doing equations much longer than you've been doing expressions, so this should be pretty easy. An algebraic expression or equation is simply an equation that includes a variable, some numbers, and an equal sign. There's 3 steps. Really easy steps that you can follow to solve any equation. The first one would be to isolate the variable. The word isolate means to keep the variable all by itself. So when you see a variable, whether it's on the left side of the equation or the right side of the equation, you can keep it there, but you want to get rid of everything else that's on that side of the equation. Well, how do you do that? In order to get the variable by itself, you had to get rid of the other things by using inverse operations. Inverse operations are just operations that are opposite of each other. So if the equation has an addition sign in it, you're going to subtract to get rid of it. If it has a subtraction sign in it, you're going to add to get rid of it. If it had multiplication, you would, you guessed it, divide. If it had division, you would multiply. Inverse operations. Think of it this way. If you add 3 and then take away 3, you're left with nothing. If you subtract 5 but then add 5, you're left with nothing. So we're going to isolate the variable, get it all by itself. How do we do that? We're going to use inverse operations to get rid of whatever numbers might be alongside of the variable. There's one more really important thing to keep in mind. We need to keep it balanced. So whatever I do to one side of the equation, I have to do to the other side. If I subtract 5 from the right side, I have to subtract 5 from the left side. If I add 2 to the left side, I have to add 2 to the right side. Whatever I do to one side, I have to do to the other side to keep it balanced. So one more time, there are 3 important steps for solving any equation. We need to isolate the variable, get it all by itself. We need to use inverse operations or opposite operations. And when we do that, we have to keep it balanced. Whatever you do to one side, you have to do to the other side. Now I know already when you see these equations that without doing anything, you know the answer. However, showing the steps for how you get the answer is extremely important for when we get to more complex equations. So showing the work is just as important, if not more important, than getting the answer. So let's look at how to show it properly. Our first sample problem is r plus 16 is equal to 27. I could think of this problem on a balance scale. R plus 16 is on our left side, 27 is on our right side. I need to isolate the variable. I need this R all by itself, so I have to get rid of an adding 16. What's the opposite, the inverse operation of adding 16? It would be subtracting 16. So therefore, I would have to subtract 16 to get rid of the 16 and keep the r isolated. But remember, the last step is to keep it balanced. So I would have to do the same thing to the other side and subtract 16 away from 27. You're going to see how to show this in a moment. Let's look at an example. 5 plus a number equals 19. I need to isolate this variable n. In order to isolate it or get it by itself, I need to get rid of the 5. The 5 is positive, so to get rid of it, I'm going to subtract 5 right underneath. And I have to do the same thing to the other side, subtract 5. Now when I add or subtract vertically, I put an equal sign that looks like this. A 5 minus a 5 cancels out, I'm left with nothing, and the n is by itself. On the right side of the equation, 19 minus 5 gives me 14. Therefore, n is equal to 14. I can check this by evaluating and replacing the n with a 14 and seeing if it works out. 5 plus, instead of n, I'm going to put the 14. Does that equal 19? Well, 5 plus 14 is 19, and I have a 19 on the other side, so check, it works. Let's look at another one. I need to isolate the variable. So I need to get the x all by itself, which means I need to get rid of a minus 12. In order to get rid of a minus 12, I need to use inverse operations. The inverse of subtracting 12 would be adding 12. So right underneath, I'm going to put add 12. But I need to remember to keep it balanced. So whatever I do to one side of the equation, the equal sign, I have to do to the other side of the equation. So I'm going to add 12. Again, since it's a vertical problem, I need to put a big equal sign. 13 plus 12 gives me 25, which is equal to just x, because the negative 12 and the positive 12 canceled each other out. So 25 is equal to x. We can solve it by replacing the x with its value and seeing if it's true. Is 13 equal to 25 minus 12? Well, 25 minus 12 is 13. 13 is equal to 13, so check, it works. X plus 9 equals 14. I need to isolate the variable of x. In order to do that, I need to get rid of a plus 9. The inverse operation of adding 9 is subtracting 9. So right underneath, I'm going to subtract 9. I need to keep it balanced. So if I subtracted 9 from the left side, I need to subtract 9 from the right side. Put my long equal sign. On the left side, I'm left with an x. These 9s canceled each other out, and that would be equal to 5. Check my work. Replace the x with a 5. 5 plus 9, does that equal 14? 5 plus 9 is 14. 14 is equal to 14, and check, it worked. Let's try this one. Y minus 21 equals 35. I need to isolate my variable of y. The inverse operation of subtracting 21 would be adding 21. I need to keep it balanced, so I'm going to add 21 to the other side. Put my equal sign. Y, these cancel out, equals 56. Evaluate to check. 56 minus 21, does that equal 35? I might have to do some work on the side. And yeah, 35 is equal to 35. Check, I did it correctly. All right, let's do one more example and then it's your turn to try some. I have 45 equals x plus 15. I need to isolate the variable of x. In order to do that, I need to use inverse operations. The inverse of adding 15 would be subtracting 15. Right underneath, I'm going to put subtract 15. I need to keep it balanced, so on the left side, subtract 15, put my equal sign. 45 minus 15 gives me 30. That's equal to x because these 15s canceled out. Let's check it by replacing the x with a 30. 45 equals 30 plus 15. What is 30 plus 15? That would be 45. 45 is equal to 45, so check, it works. Okay, it's your turn now. So you're going to have to show all of the steps on a piece of paper or on your whiteboard, and then pause it and check the next screen to see if you did it right. Okay, go ahead and pause. Okay, I'm back, and here's an example. Now this draw the river to separate the equations is not needed, this blue line. That's just to kind of help you show both sides. Subtracted 16 from both sides, r is equal to 11, the check is done. Your problem has to look like this in order to get it correct. Okay, copy down this problem, try it, pause the video. Let's see how you did. Did you subtract 2 from both sides and show that x is equal to 11? Did you substitute and check your work? Great. Let's try another one. Copy down 8 equals m minus 3. Pause the video. In this one, did you isolate the m by using inverse operations and added 3 to both sides to get 11 is equal to m? Then to check, did you replace the m with an 11 to see that 8 is equal to 8? Okay, we're going to try one that has some decimals in it. The same rules apply. Isolate the variable, use inverse operations, keep it balanced. However, you might have to do a little bit of work on the side. So I'm adding, our 15 is equal to a plus 5 and 2/10. Copy it down, don't forget about your decimal rules, and go ahead and solve and pause. Okay, let's take a look at this answer then. Did you subtract 5 and 2/10 from both sides? You probably had to do some work on the side. 15 minus 5 and 2/10. You had to line up decimals. Remember, 15 is a whole number, so I need a decimal and a 0 so that I could line those decimals up. I needed to do some borrowing to make this a 10. This would become a 14. 10 minus 2 would be 8. Bring down my decimal. 14 minus 5 is 9. So 9 and 8/10 would be equal to A. Replace it. Solve again on the side. You probably had to do 9 and 8/10 plus 5 and 2/10 to prove that it was equal. 15 and 0/10 is equal to 15. So the work on this side is great. Don't erase it. Keep it off to the side. But I do have to see all of this work as well as your check on every problem you do. Let's give one more with a decimal a try. All right, this time I have 1 and 34/100 is equal to a minus 5 and 2/10. Pause the video, solve, and then come back. In order to solve this one, I'm subtracting 5 and 2/10, a minus 5 and 2/10. The inverse operations would be to add 5 and 2/10, keep it balanced, add it to both sides. I had to add a 0 here so that when I added, I got 6 and 54/100. To check the work, I need to replace the a with 6 and 54/100. Again, you probably need to do some work on the side to be sure. Don't trick yourself into thinking it's definitely correct without doing a proper check. 4 minus 0 is 4. 5 minus 2 is 3. Bring down that decimal. 6 minus 5 is 1. And yes, 1 and 34/100 is equal to 1 and 34/100. Okay, it's your turn to practice. I need to see with all of your problems, I need to see all of your work that you balanced your equation, you used inverse operations, and you did checks for your work. So come see me for a worksheet and prove that you now know how to solve one-step addition and subtraction equations.